Zöld Lámpa. Ön a Klímapolitikai Intézet podcastjét hallgatja.
Hello everyone, welcome to Green Light, the podcast series of Climate Policy Institute. Today's guest is Dr. Bert J.M. de Vries, co-founder of the Institute for Energy and Environment at the University of Groningen. Dr. de Vries holds a PhD from the University of Groningen, the Netherlands. In his doctoral thesis, he studies sustainable resource use. Dr. de Vries, thank you very much for joining us today. My first question is connected to one of your fields of expertise. As a co-founder of the Institute for Energy and Environment, you can call yourself an expert in both fields, probably. And I would like to know what an ideal energy mix should look like from an environmental point of view. And I would also like to know if it's uniform for all regions and situations, or if the situation is more nuanced than that, and we need different energy mixes for different regions and different situations.
Thank you. I'll try to answer the question. It's, if I understand it correctly, mostly about energy, and energy in relation to climate and climate policy.
And the environment.
Yes, environment, of course, is intricately related to energy issues. But usually, in my work the last 30, 40 years, we initially thought, if we talked about energy, about dependency, especially on oil in the Middle East and other countries. Also important were the air pollutants, for example, in cities from burning fossil fuels and from transport. It was only in the 90s that CO2 became an important topic and its contribution to climate change. So the last 10, 20 years, many countries, certainly in Europe, are now faced with the need for an energy transition. And this energy transition is, let's say, uphill. In the past, it used to be downhill because we got cheap oil, we found huge amounts of cheap gas. So we started to spend energy very inefficiently. Now we have another energy transition, which is in a way uphill in the sense that we have to phase out the cheap, relatively cheap fossil fuels and try to find ways towards non-carbon energy options like solar photovoltaic, energy efficiency, etc. I think this new energy transition is less uniform than the previous downhill one. Because downhill, it meant simply that you stop using coal and you go for oil and gas. Now you are much more dependent on the local situation or the regional situation. If in your country, like in Morocco or Tunisia, you have in principle a lot of solar energy and you can finance it, you can become almost independent based on solar energy. In my country, the Netherlands, we have now thousands of megawatt based on wind turbines, mostly in the North Sea. In a country like Hungary, you may benefit from large areas, maybe for biomass, maybe also using wood from forest, but also large areas for solar panels. So the new situation is, the first goal is to become much more efficient with energy. And the second goal is then to look for the role of local, regional resources. And in the process, you have many benefits, which we call co-benefits, because if you phase out fossil fuels, you also, in the process, usually have less pollution, for example, in cities, and less dependency on, for example, the Middle East.
Thank you very much. You've been mentioning renewable energy sources multiple times, and my next question is centered around this field. I would like to know what progress the exploitation of renewable energy sources made so far, and what further progress it has to make to become more dominant in the global energy mix.
Interesting question. I would like to focus more on Europe than on the global situation, because globally you have big differences. So let's focus on Europe. And I think in Europe we have seen three important changes, which were even a surprise for us because we have been making energy models since the 80s. I did, with colleagues, a lot of work in the 90s for the IPCC on climate change. And, for example, the rate at which the cost of renewable energy, particularly wind power and solar photovoltaic power, has gone down is faster than we had expected. It is really very fast learning by doing. So it meant that already 5, 6, 7 years ago, you could generate electricity from wind turbines and from solar photovoltaic at lower cost than you would generate with a coal-fired power plant. So this was an enormous push for renewable energy, and you saw already massive investments in solar and wind. In fact, much more than in biomass, because we had big expectations also with biomass, but that's giving a number of problems. So at the moment, I would say the big surprise, positive surprise, is the introduction of wind and solar and the still going on decline in cost. However, at the same time, we now face a system problem because we used to generate electricity with big power plants, either coal or oil, gas or nuclear. And then you can just follow demand. So if the demand goes up, you simply increase the power of your plant. Unfortunately, you cannot simply switch on the sun or switch on the wind. So what we are faced with now is that we have a lot of power coming from solar and wind in certain periods, and certainly not at night from solar, for instance, and demand will not go to zero. So how do we match this? And this is now the big challenge, I think, over the next 20 years for many European countries. There are a number of solutions. The first one is work together by big transmission lines, because we did also calculations of this long ago. If you have anticipatory apps with which you can find out how the weather will develop over the next 24, 48 hours, then you can more or less predict how much power will come from the wind and up to a point also from solar. And then if you have a good transmission system, you can actually move the power to the places of demand. For example, from the North Sea to parts of France, or from northern Germany to southern Germany. The trouble is you have to have these big transmission lines. And there you have sometimes this phenomenon called NIMBY, not in my backyard. So people don't want the transmission lines. The other option is to go for something which is difficult, but which is possible, which means storage of electricity. We have a number of ways to store electricity. For example, you can pump up the water, and then if you need it, you use turbines to generate power. But we also have more and more powerful batteries. And we also have other devices. So what I see here is that a breakthrough in storage will be a very important topic. And I think thirdly, what matters also very much is that we are going to organize the demand of electricity much more carefully at the community level. Because what you would like to do is, if a factory, for example, uses electricity, you would like to tell them, if you use it when we have solar or wind at low cost, you get it cheaper. But if we don't have it, you have to pay much more, or preferably, you simply switch off your machinery. And this is called load-side demand management. So I mentioned three options, which I see as very important for future energy systems. And this is true for all countries, but each, of course, with their own constraints and possibilities.
The fact that we need to cut our emissions to stop and reverse the threats posed by climate change is becoming widely accepted. However, many greenhouse gases remain in the atmosphere for decades or even centuries after their emission. I would like to ask you, as someone with an abundant experience in climate modeling, do you see a chance for us to limit global warming to 1.5 or 2 degrees Celsius compared to pre-industrial levels?
Well, do I see a chance? To be honest, I think the 1.5 degree target is just wishful thinking. Forget about it. The 2 degree...
More and more people say that, unfortunately.
Yes, but I could have told you already 1-2 years ago. I mean, this was just not possible. And why not? Well, basically for 2 reasons. The first one you mentioned already. Once you emit these gases, which we were doing the last 200 years, they stay in the atmosphere for quite a long time. Even methane, which is a strong greenhouse gas, stays 10-20 years, but carbon dioxide, maybe 100 years. So you have already a delay in the system, inertia in the system. So to really bring down the temperature rise, you would have to almost take out greenhouse gas from the atmosphere, which we are not going to do at any massive scale. The second reason is that we are so, you might say, addicted to the use of fossil fuels, which still make up 80 to 90% of our energy use, that it's almost impossible to have such drastic reductions. Because imagine what it means. It means that if you really have to do, as we calculated, if you really have to go down to 50% of the present use globally within a few decades, that would mean that also in developing countries, you would have to stop the growth of private cars. It means that you would have to somehow stop the building of big factories for concrete, for metal, etc. So this is not going to happen. So the consequence is that unless we have extremely rapid improvements in efficiency and extremely rapid changes towards non-carbon energy options, we will simply overshoot the target. And then we made already 30 years ago many calculations, and these have been improved every year. So in the recent IPCC reports, you can see the impacts if we exceed 2 degrees Celsius. And unfortunately, at 2 degrees, we may already experience more severe storms, more severe droughts, etc. And they may also hit not the rich people who caused the problem, but many of the poor people, unfortunately. If we have not the policies implemented, which are now, for example, in the European Green Deal or in the Paris Agreement, then we may even go to 2.5 or 3 degrees. And my personal guess is that humanity is so conditioned or addicted that only if we have some serious events happening, really serious climate change related events, we will be willing, politicians will be willing, companies will be willing, people will be willing to change behavior and really follow drastic policies. So, to answer your question, probability of 1.5 degree, next to 0. Probability of 2 degrees, non-zero. It's possible, but rather implausible because of all the societal changes and behavioral changes. Possibility of 2.5 to 3 degrees, quite high.
What is the role of Europe and the EU in particular in reversing climate change, since we're not the largest emitters, we are not pioneers in the renewable energy industry, our population and our GDP are becoming less and less significant as a share of global figures. So aren't we becoming a marginal factor in the global struggle against climate change?
Well, you mentioned a number of features about Europe which I'm may find not really relevant, in the sense that it's not so important that Europe is no longer the biggest economy in the world. I mean, it's true that for climate change, the role of policies and attitudes in the United States of America and in China will maybe be the most important. But at the same time, Europe can be an outstanding example of a society which has developed, let's say, a certain kind of political governance which involves the people, called democracy. It also is a region which has developed in the welfare state a certain degree of solidarity, something which I see also here in Hungary quite clearly, but also in other European countries. This is different from the United States and from China. And in my view, this very idea of welfare state and solidarity are crucial to realize climate policies with support from larger groups of the population. Because if we don't want to go into an autocratic rule, let's say like in China, and we don't want to let the market dominate what's happening, which is partly at least the philosophy in the United States, then Europe can be leading in the type of governance which will help us to implement the necessary climate policies. So in that sense, I'm, despite the things you mentioned, which are correct, optimistic about Europe's potential role. And I hope Europe is going to fulfill this role.
Dr. de Vries, thank you very much for being here with us and joining us today. And thanks for all our followers on Greenlight podcast of Climate Policy Institute. Thank you very much for being here with us today. And we're really looking forward to meeting you at our next podcast as well.
Pleasure. Thank you.
Thank you very much.
Zöld Lámpa. Ön a Klímapolitikai Intézet podcastjét hallotta. További tartalmakért látogasson el a klímapolitikaintézet.hu honlapunkra, és kövessen minket a Facebookon és az Instagramon.